Hello friends, this video on sequence and series part 1 is brought to you by examfear.com. No more fear from exam. Introduction to sequence. Sequence is nothing but an ordered list which has a pattern. To repeat, sequence is nothing but an ordered list which has a pattern. For example, money in piggy bank. So you have this piggy bank. So I'll draw a piggy bank for you. This is a piggy bank which is at this hole where you can put money, and this is the stand. So this is a piggy bank. I'll make a decoration, smiley face. So this is a piggy bank. This is a piggy bank where you do put money. Now let's suppose I'm talking about 1st of Jan. So your dad told, okay, let's start the account on 1st Jan. Since it's a new year, I'll give you 100 rupees, and every alternate day, or every next day, he'll give you 10 rupees each. For example, 2nd Jan, he gave you 10 rupees. On 3rd Jan, again he gave you 10 rupees. 4th Jan also, he gave you 10 rupees. So daily he keeps giving you 10 rupees. Now, at any point of time, if you want to know how much money you have in your piggy bank, then you can use sequence. For example, on Jan, the amount was 100, Jan 1st. On Jan 2nd, it was 100 plus 10, that is 110. On Jan 3rd, it was 110 plus 10, that is 120. On Jan 4th, it is 120 plus 10, that is 130. And Jan 5th, it is 130 plus 10, 140. Similarly, it will keep increasing. So if you see, there is a pattern here, 100, 110, 120, 130, 140. That's a pattern here. The pattern is that the difference between any two consecutive number is 10. If you see 110 minus 100, that is 10. 120 minus 110, 10. 130 minus 120, 10. 140 minus 130, 10. So you see there is a pattern here. Correct. So such kind of ordered list which has a pattern is called sequence. We have different kinds of sequence. We'll go through it. But just understand what is sequence. Sequence is nothing but an ordered list. The list is ordered. It is in the ascending order. That is, it increasing. This is from small to big, increasing. It can also be decreasing. The list can also be from big to small. But this should be in order and should have a pattern. Then it is called sequence. Let's take one more example of sequence. For example, on the month of Jan, you have solved, let's suppose, 4 questions, 4 maths questions every day, 4 maths questions every day, per day. Now your teacher is telling you that you keep increasing your count so that every month you double. That is, in the month of Feb, you should go for 8 maths questions every day, 8 math question per day. In the month of March, he expects you to go for 8 into 2, that is 16 questions, math questions. Similarly, for April, he expects you to again double it, 16 into 2, 32. So if you see, there is a pattern here, 4, 8, 16, 32, this becomes 64, you keep going. So there is a pattern that each number is double. For example, 4 into 2 is 8. 8 into 2 is 16, 16 into 2 is 32, 32 into 2 is 64. That means there is a pattern here. All the numbers are in the ordered list. It is an increasing order, and there is a pattern. The pattern is the nth term and n plus 1th term should have some relation. So there is a relation here. So there is a pattern. Any kind of pattern is called sequence, and that pattern should be ordered list. We'll go through this in details. Just understand what is sequence. Sequence is nothing but an ordered list which has a pattern. So we'll define sequence now. Sequence is an ordered list of objects. As we've explained in the scenarios above, that money in the piggy bank, or if you're asked to double the number of questions, those things are pattern. So mathematically, sequence is nothing but an ordered list of objects. For example, we have seen in money bank it was 100, it became 110, it became 120, 130, 140. This was the total amount in the piggy bank. Or in case of maths question, you are asked to solve 4 questions, then 8 questions, then 16 questions, then 32 questions, then 64 questions, and 128 questions. The list keeps increasing every month. So you see there is a pattern here. In first case, the diff is constant, and that is 10. And here, not the difference, but the division. Here the division, because this by this, or this by this, this by this, the division is constant, and that is 2. So in both the case, both are ordered list and both are having a pattern. So let's take one example. We have to write 5 elements of the sequence where Tn is equal to 2n plus 3. So now what we'll do, we'll first say n is equal to 1. So n is equal to 1, what we get? T1 is equal to 2 into 1 plus 3, and that is nothing but 5. Similarly, T2 is equal to 2 into n is equal to 2, here we'll put 2 plus 3, that is 2 into 2, 4 plus 3, 7. Similarly, T3 is equal to 2 into n is 3 in this case, plus 3, that is 9. Similarly, T4 is nothing but 2 into 4 plus 3, that is 8 plus 3, 11. And T5 is nothing but 2 into 5 plus 3, that is 30. Thus we can say that first 5 terms of 2n plus 1, this is the 2n plus 3 is the tnth term, is equal to 5, 7, 9, 11 and 40. Similarly, let's take one more example. So we have to find for Tn is equal to n square, first 5. Here also what we'll do, we'll put the value of 1, n is equal to 1, T1 is equal to 1 square is equal to 1, T2 is equal to 2 square is equal to 4, T3 is equal to 3 square is equal to 9, T4 is equal to 4 square is equal to 16, and T5 is equal to 5 square, that is 25. So what we have got, now we'll write first 5 terms is equal to, sorry, this is not 1, this is 1, 4, 9, 16 and 25. Similarly, let's take one more example. Tn is equal to n cube. Here also we'll do the same thing. So here we'll write here T1 is equal to 1 cube, that is 1. T2 is equal to 2 cube, that is 8. T3 is equal to 3 cube, that is 27. T4 is equal to 4 cube, that is 64, and T5 is equal to 5 cube, that is 125. So if you see the series, what we get is the 5 term series is equal to nothing but 1, 8, 27, 64 and 125. This is our answer. So what we have done here, we know in the nth term, we have put the value of n is equal to 1, 2, 3 and 4 and 5 to get T1, T2, T3, T4, T5, and thus that is the answer. Let's take one more example. Here we have to find the nth term. So we are asked to find 15th term of this sequence. An is equal to n minus 2, n minus 3 and plus 5. So we have been told that An is equal to n minus 2 into n minus 3 into n plus 5. So we have to find A15. Just we have to replace n with 15. So replacing n with 15 we get 15 minus 2. This is 15 n minus 3. So this becomes 15 minus 3 and this becomes 15 plus 5. So this becomes 15 minus 2 is 13. 15 minus 3 is 12 into 15 plus 5 is equal to 20. So what we get is, this is nothing but 13 into 12 is equal to 156 into 20, and this is nothing but 3120, and this is our answer. Very simple. We have to find 15th term. We have been given the equation of an. Just replace n with 15 and you get the answer. We'll now see sequence types based on number of items. So we have, based on number of items, we have finite and infinite sequence. If we say that the sequence is finite, that means it has definite number of elements. For example, I say that their sequence which is 2, 4, 6, 8, 10, 12. This is the sequence and starts with 2, ends with 12. And the difference is always 2. So it's a sequence and the number of items is 1, 2, 3, 4, 5, 6. So there are 6 items. So it is finite. In other case, let's suppose the same sequence, or let's suppose we have sequence 1, 2, 3, 4, 5, 6. It goes till infinity. So in that case, the number of element in this sequence is infinite. So this is infinite sequence. It's pretty simple. Sequence which has finite number of elements is called finite sequence, and sequence which has infinite number of elements is called infinite sequence. Let's learn the sequence based on the pattern types. We have arithmetic sequence, geometric sequence, and Fibonacci sequence. So based on pattern types, we have 3 types of sequences: arithmetic sequence, geometric sequence, and Fibonacci sequence. So first, let me touch upon all these. In case of arithmetic sequence, the difference is constant. The difference is equal to constant. So that means an plus 1 element minus an. You take any n element for this. The difference is constant. In case of geometric sequence, the division is constant. Division is constant. That is, you say any an plus element and we divide by an, you get some constant number. I'll say k1, k2, so that you don't get confused. Both are different values and both are constant. For Fibonacci series, what happens is t of n plus 2 is equal to t of n plus t of n plus. So every third number is sum of first 2 or the preceding 2 numbers. I'll take examples of all these 3. In case of arithmetic sequence, for example, we had this piggy bank thing where the value was 100, 110 rupees, 120 rupees, 130 rupees. This was the value of money in the piggy bank on each passing day. So here if you see, the difference is constant. The difference here is 10. The difference here is 10. The difference here is 10. Here also difference is 10. Here also difference is 10. So such kinds of sequence is called arithmetic sequence. We also call it AP. In case of GP, let's take the example of the number of questions solved by the student. In first month, he was supposed to solve 4 questions per month average. In second month, 8 questions. In third month, 16 questions. In fourth month, 32 questions. In next month, it was 64 questions. It carries on. So if you see here, 8 by 4 is equal to 2. 16 by 8 is equal to 2. 32 by 16 is equal to 2. 64 by 32 is equal to 2. So if you see here, the division is constant. You take any number and you divide that number by the preceding number, the division is constant. So this type of sequence is called GP. Now let's take example of Fibonacci series. So if we have 0 and then 1, 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 3 plus 2 is equal to 5, 5 plus 3 is equal to 8, 8 plus 5 is equal to 13, 13 plus 8 is equal to 21, 21 plus 13 is equal to 34, 34 plus 21 is equal to 55. You keep increasing this. You can make this 9 and 89. So this kind of sequence is called Fibonacci series. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.